All right, so basically what we're doing here is we're going to compare the two ways that Jill can sell her lemonade. So the first way is that she has a startup cost of $30 she has to pay. So that, if you think about profit-wise, that's going to make her start at a negative 30 profit, right? If she has a cost, the cost is the opposite of a profit. So, let's see. All right, so let's just highlight that, and that we know that that's going to be a negative because it's a cost right there. And then, but then when she sells it, she's going to have a profit. So that she'll make $1.50 for each one that she sells. Okay, and then the other option is strictly there's no startup cost. It's already built into it, so they're just going to sell it for $75 a cup. Okay, so obviously if they started and they sold like 1 cup, we would know which one has a better option. But at what point will they have the same profit? And if we graph these two equations, that would be where we'd see an intersection. So you might be tempted to graph it, and that could be one method to do this. All right. So let's look at the scenario 1. So this is let's look at what is it called? Let's call it the first one. In that case, the profit. I'm going to say, let's say over here, let P of C be profit in terms of number of cups sold. So the number of cups sold, that's like your X. And P of C is like your Y. Okay? All right, so let's just set it up that way. We can say Y is equal to... the first one is, there's a starting amount of negative 30, so that's our y-intercept, right? And we have 1.5x. All right, so this is the first company. We make more per cup, but we have that starting cost. The second company is pretty simple. We don't have any starting cost, so that would be 0 here. I don't need to write 0. The second company is y is equal to 0.75 x. For each cup they sell, they make 0.75, okay? So taking a look at this, we could graph it, but now that we know how to use substitution and elimination, we can see that in both cases here, y is isolated, right? So it really doesn't make any difference if I substitute this y value here or I swap this y value here. So all we have is that 0.75x is equal to 1.5x minus 30. Okay? And then what I could do is I'm going to decide, well, maybe I want to have x on the left. I don't know if you want to have it on the right. It doesn't really matter. So if I subtract 1.5x, I'll have x isolated on this side. So I subtract 1.5x from both sides. Negative 0.75x. And depending on how you set this up, I could have done a better job so I didn't have negative coefficient. Equals negative 30. Times them both by negative 1. So let's just make them both positive. And then I'm going to divide by the coefficient, 0.75, right? Undo the multiplication. And x is equal to... Let's get the calculator out. All right, so that was 40, right? Now, you could do that without a calculator, but since we can use it, why not? Okay, so that is x. X is, or I guess it's kind of like C here, the number of cups sold. All right, so we know that's 40. And does that answer our question? How many cups would need to be sold for both scenarios, and what would the profit be for that? Well, what would the profit be? Well, we could go ahead and find out what that is. So the cups sold would be 40, and the profit, let's find out what that is. Let me change my color of my pen here. So profit, we can say, well, y equals, it doesn't matter which one we do, but let's just do this one, 0.75 times 40. Okay, so y equals, what is the profit? Okay, well, 3/4 of 40, basically 0.75 is 3/4 of 40, so that's 30. So that'd be the profit of $30, okay? All right, so at that point, it doesn't really matter which company exactly at that point, and obviously beyond that, we've already paid for our costs and made some profit. So beyond that, the first company is much better. Prior to that, you'd be better to go with the second company because you don't have those startup costs. Okay. All right, that's that.